students, welcome once again to my channel. Now in this section we have an integration over here, so we have to solve the integral over there. So basically what we are going to do is to use the substitution method, because we have e exponent s minus 2. We have to use the substitution method. So basically we let u equal to e to the power s minus 2, and therefore making u the subject, so from here, making e exponent as the subject, here we have u plus 2. So let's call this one 1 and let's call this one 2, and therefore from this, another thing that we can also do is that we also know that u squared here will just be alright, so this is half. We're going to bring the half 1 over 2. So this is so from here we just have square root both sides. We just have so we square both sides rather. When we square, we have u squared and we have e to the power s minus 2 here. So basically e to the power s will be u squared plus 2 in this case, right? So you can have something like this, and then from here what we'll do is that we differentiate s with respect to u, right? So we have 2u here, and therefore our dx here will be equal to 2u du, right? It will be 2u du, and then we have, and then what is left is the e to the power x in this case, right? So the x here will just be 2u du, and then e to the power x in this case. So let's substitute the whole of that. So substituting that into the equation, we have just u. So we have just u here, because u represents the whole of that, and therefore another thing that we can also do here is that we can write this as 2u du. E to the power s is just u squared plus 2u. So it will be the square root of e exponent s minus 2 here, which is just u. So we replace that one as u, and then multiplied by dx. Dx here, our dx here is just the whole of that. So we have 2u du being divided by u squared plus 2 in this case. So from here we can have something like so from here we have just 2 outside, and we have u squared over u squared plus 2, and then we have with respect to du, right, in this case. So this is what we have, and then from here what we are going to do is that, okay, so another thing we can do is that we can add and subtract 2 at the numerator. So we have plus 2 minus 2 divided by u plus 2, and then du. Now we'll see the reason why I've done it this way. So you realize that from here, right, we can have u squared plus 2 here divided by u squared plus 2. So what I did was to make the numerator the same as the denominator in a way. So we have minus 2 here, then u plus 2. So these will cancel that. Remember, it's respect to du, and then I'm left with 1 du, and then also we can also have 2 over u squared plus 2 here, and then du, right? So over here we can have so integrating this, we just have this to be, which is u, right? So quickly let me take this out so that I can put everything in a bracket, and then minus, when we integrate this, we just have the square root of the arctan, which is the tan inverse of just a u over root 2 here plus c, and therefore we are just going to get 2, and then u here is just u we said from the beginning is that square root of s minus 2, and then we have minus 2 2, and then we have the arctan, the tan inverse of so the u here is just e power s plus 1 here divided by 2 here, and then plus c, and that will be the answer for the integral. So thank you very much for joining me in this session, and I will see you guys in another section.